All right, so power is the amount of energy transferred per unit of time. The amount of energy transferred per unit of time. Our formula this is a capital P because we're using the lowercase p for something next unit. So capital P, power equals work divided by time. And our unit is the watt, which is a W, named after James Watt. So you hear, especially with like cars and stuff, 750 horsepower, 900 horsepower. 1 horsepower is about 750 watts or 0.75 kilowatts. So your parents pay their electricity bill based on their usage typically, and it's going to be in kilowatts per hour. So kilo, remember, is at 1,000. So 1,000 watts is 1 kilowatt. All right, I feel like this may be on the test. I don't know. If you double the power, that means you can do the same work in half the time, or you can do double the work in the same time. If you double the power, that means you can do the same work in half the time, or you can do double the work in the same time. So if you make this a 2, you can either have 2 and that'd be a 1, right? Or how else could you make this equal to 2?
You could do 4 over 2.
4 over 2, yeah. So that you'd be doing double the work in twice the time, yes. You could also very easily say, if it was instead of 2 over 1, 1 over 2 is 1 over 2 is 1. Okay, I feel like I shouldn't have gone here with the math.
Okay.
Those equal the same, right?
Yes, ma'am.
Okay.
Okay, well, yeah.
Right, okay. So same amount of work in half the time, or double the amount of work in the same time. Okay. All right, this is not my drawing. I got this from a physics textbook, but it has man and woman each moved a TV using 56 joules of work.
Wait, can you go back up again?
Did you get it? All right. So you got 56 joules. The woman used a pulley and moved the TV in 2 minutes. The man carried it up in 12 minutes. How much work did each use? I told you how much they used. How much did they use? 56 joules. They both used 56 joules of work. Okay, first off, props to the woman for using a pulley to get the job done. Major props to the man, though, for being willing to carry up a TV up a flight of stairs for 12 minutes. His biceps, his triceps, his quad, everything must be burning at the end of 12 minutes. Right, so I think he deserves, I think we need to recognize his work there. Okay, but regardless, from a physics standpoint, they still both use 56 joules. Their power, however, is going to be different. So I'm going to put the woman over here and the man over here. Now we have 2 minutes and 12 minutes, but do we use minutes? No, we don't. We use seconds. So the time for the woman was 2 minutes. And since there's 60 seconds in 1 minute, this would be 120 seconds. Okay, my power is equal to work over time which becomes 56 over 120 seconds. This is joules. This is seconds. That's going to give me 0.47 watts. Everyone understand how I got that? Pretty simple, right? Like, that's straightforward.
You divided it?
I did. I divided it.
That's it.
That's it.
And that gives you your P?
That gives me my power.
Which is
Big P. And my man here did 12 minutes. And 12 times 60 is 720 seconds. So again, power is equal to work over time, which is going to be the same 56 joules over 720 seconds. He only generated 0.08 watts of power. So who generated less power? The man did, right? 0.08 is very much smaller than 0.47. All right, I want you to try my rope climbing example, please. Maybe we don't throw the sharpened one?
Yeah, roll it. I think it's unplugged.
It is. I got it.
Just use your teeth, sure, right?
My teeth? I don't use the blade. Yeah. This part. Why would this take?
I don't know, where are my staplers at? Did y'all about pass all around the staplers to staple your lap?
There's one's right here.
Did they stop? Keep it.
Wait, I didn't get a lot.
Here I am blaming y'all for not passing out the staples and it's been passed out the lab. Alright, could you rotate my staplers around, please?
What is this?
I did, I forgot.
It's like, what is this?
No, it was
700 divided by 2.
You got time to work? Isn't that a song? Work it? Why not work? Okay, we're gonna go over. Alright, so this is a two-stepper. Y'all ready? 700 Newton climbs at a constant speed to a top of an 8-meter vertical rope in 10 seconds. Calculate the average power by the student to overcome gravity. So my power is equal to my work over time. Okay, which is going to be equal to my work divided by 10 seconds. I don't have my work yet. So to get my work equals force times distance. Yes, my stapler is very powerful. Be nice to it. It's mine. Work is equal to force times distance. So I'm going to do 700 newtons because newtons means force. My distance is going to be 8 meters. So 700 times 8 is what?
It equals 5,600.
5,600 what?
It's worth
Joules. So from there, I can put this back into my power formula. 5600 over 10.
That is 560.
560 watts.
Because that's the power.
That is my power. Now, what if I wanted to ask you how many 60-watt light bulbs could I power with that power generated? Like if I could plug you up to like a big hamster wheel type of thing, and you could spin the turbine like the dams and stuff do, how we generate power with like the wind turbines. If I could put you on a hamster wheel and you use all that power to power 60-watt bulbs, how many could you power? What would you do?
You divide by 60.
You would divide that by 60. And 560 divided by 60 would be 9.333.
So just 9.3.
Yeah. Any questions? That's about as hard as it's going to get on the test. That's it.
I know how to do that.
So we've still got to talk about energy transfer, but like you know that stuff because chemistry. All right. Look at your lab for me, please. When you walk around the classroom, are you doing work?
Yes. No.
All right, let's look at it. What is my force when I'm standing here? Just when I'm standing here walking around the room, what's my force?
Down. You're pushing.
I promise you my feet hurt when I get home. Why?
Because you're putting force onto them.
Because I'm putting force on them. So my force is down. And if my distance is around the room, am I doing work?
No.
No. Oops. Force.
Oh my God, yesterday was 2.
Oh no, I missed it.
Force and distance are perpendicular. All right. What about when I walk down the stairs? Am I doing work?
Yes.
Yes. All right. If my force is negative and my distance is negative, because they're both going down, is my work done positive or negative? Just think about it. If my force is negative, because it's a weight, it's going down, and my distance is negative.
It's going to be positive.
Why?
Because negative is times negative or divided by negative positive.
You're so smart. All right. Now, the other physics teachers have scales in their room. I don't even have a scale in my house because that number that it outputs does not determine who I am. And plus, I don't like to see it spin.
I weigh myself.
So, I am not here to tell you what your weight is. I'm not going to tell you what to put down as your weight because I don't know. I don't know. You're going to do your best guess or make up one completely that makes you feel better as a person. I don't care. And that's what we're going to use. Okay? So,
Can you use mine as an example? I weighed myself this morning.
Are you okay?
181.
you want me to use 181? Okay. So, I'm going to use a volunteer's 181 pounds. You do not have to write this. You just have to follow along with me. If you don't know it, put your best guess. If you're not comfortable with your best guess, make up a number. I don't care. All right, there are 2.2 pounds per 1 kg. So if I weighed 181 pounds, I would put that there. I'm going to put my conversion right there. I'm going to do 181 divided by 2.2. Oh my goodness, that was not the divide button. 181 divided by 2.2. It's going to give me 82.3 newtons. That's my force. Nope, that's not my force. Sorry, that was me being silly. Kilograms. And then F equals MA, 82.3. What does my acceleration do to gravity? 10. 10 for easy math. Means I have a force of 823 newtons.
So you just multiply whatever you do by 10.
By 10. Or move the decimal. All right. We're going to go outside. You are going to walk up the stairs at least, let's say twice, and we get the average. Okay?
We actually do that.
Yeah. We are not going to fall. We're gonna walk up very slow. You can walk up very slowly, right? I'm not here to judge your time. Walk up super slow. That's fine. Our vertical displacement. Uh-oh, hold on. 100. I did 181 times 1 divided by 2.2. All right, we're gonna make my vertical displacement 3.37 meters. We're only gonna do one set of stairs. Okay, so everyone's gonna have that same displacement of 3.37. Okay.
When you mean by outside, you
Your-
mean outside?
No.
Okay.
Hallway. Your force is going to be your mass times your acceleration due to gravity. So whatever you put there. So Jose would have 823.
So I put that there?
Yep.
Where?
But his might be different than yours. I don't know. I'm not here to live your life. And so you're going to take 2 times, put them on here. We will average them up. Then you're going to, because we're only going to be out there for a couple minutes, you're going to come back in. Or you're going to go back up to the bottom. You're going to do the same time for running. Remember, when we average, we're going to add them up and divide by 2. Now, I say running. I don't mean like I actually need you to run. If you're not comfortable, it's a bad news bears for me to run up the stairs. I'm more likely to hit my face, right? But I could increase my pace a little bit. Okay, so I'm not asking you to run. Your feet have to touch the stairs at every point. Yes, ma'am. You would add them and then divide by 2. Your feet have to touch every stair. There's no skipping stairs to make your time go faster or anything like that. You have to walk up it twice, run, speed walk a little bit faster up it twice as well. All right? Any questions?
Maybe you say like each foot, so does that mean like walk up one with the same foot, you just like.
You can alternate your feet and go left, right, but you can't skip over 2.